I'm responsible for FTTX solution planning in Huawei technology. And so today, I'm going to talk about the very edge of the network, so the broadband access part, and to have our understanding and also the practice on how to introduce a kind of software definition or virtualization into the FTTX domain. Since it is, till now, it is still a lot of huge investment part of the broadband network. So I think that will be also quite essential topic. And we cooperate with our global customers on this kind of exploring and also the practice. So that's the purpose we'd like to share. And at the beginning, I think today it is the fourth day of the SDN and FV World Congress. Just in the past 3 days, I have already heard several discussions on the kind of intent-driven. And so what kind of intent? What does it mean? Actually, the first speaker, Stefano, just gave a very good example on the deployment on intent-driven mobile network. He just to describe how big the room is, how many of the subscribers is needed, and the network is deployed. Why don't we also introduce this kind of concept into the fixed network? So this is a kind of intent. I would like to mention that. In the past, we may say that the broadband network driven more or less mainly by the broadband speed. In the past 20 years that we passed the generations of kilobits, megabits, 10 megabits, 100 megabits. And now it is not a problem from the technical perspective to provide 1 gigabits per second to each of the home. So in the past, it's a speed driven. But now, since that when the speed has already reached to this level, to this stage, to hundreds of megabits to gigabits level, it seems that the speed is not the bottleneck, at least not the mainly bottleneck for the broadband network anymore. And so what should be considered by the broadband network construction is more or less moving to the experiences. And so this is kind of one of their experiences is user experiences, especially for the very higher bandwidth consumed services user experiences. For instance, video. We may agree that video will be roughly the most attractive services on the broadband network. Just this year, the Russian World Cup is already broadcast with the 4K ultra high definition video, right, and HDR technologies. And just in 2 years later, the Tokyo Olympic Games by 2020 is announced to be broadcast with 8K ultra high definition video. So that drives the network capability will reach to another level on the broadband resolution perspective, which consumes relatively consistent around 100 megabits per second. Imagine that we need to guarantee this consistent 100 megabits per second from the end to end, from the cloud data center to the core network, to the metro network, to the access network, to the home network, to the Wi-Fi, and to the device. It is not an easy work. And furthermore, we may expect that the virtual reality will be also introduced in the next years. Still on the sports, right? It is also announced by the Olympic Committee that by 2022, the Beijing Winter Olympic Games will be broadcasted on virtual reality, high definition virtual reality. So that will consume hundreds of megabits per second, consistent video stream. And also, we know that when we need to support the virtual reality deployment into network, it's not just the unique direction broadcast. We need the consistent communication interaction between the cloud and also the video terminals, the glasses, and for rendering purposes. And then the latency and the SLA of the network need to be increased to another level. So that's another perspective for the network experiences from a consumer perspective. And furthermore, another group and the most attractive services is gaming. Actually, what is interesting of the gaming is that the way to provide the gaming services is also changing. So in the past, gaming services is provided mainly for the players. But now, it changed that the players has already been clarified into two groups, ordinary players and also professional players. So when providing gaming services, we need to consider the experiences not just for the players, but also for a lot of audiences. So now it is not something new that there is also international gaming, e-sport, broadcast all over the world. But what is new is that the e-sport is started to be adopted by the real sport athletes committees. Also, just 2 months ago, and the esports is already accepted by the Asian Games as a formal competition games. There is also games already in the Asian Games. And there also, I heard that there also a discussion by the International Olympic Committee that by 2024 and Paris Olympic Games, probably there also a formal e-sport gaming on that. So which means that gaming is kind of a combination, actually, by all the high definition video and also virtual reality, and asking for even high quality of the network. So which means that from the service experiences, user experiences perspective, we have to consider the network to support this kind of service deployment, management, and operation in the next generation networks. So that's from the experiences of the broadband users. And we have to consider another group of people in the broadband industry is the technicians of the telecommunication operators. And the experience of them is also very important when we design or deploy a broadband access network. Just with two examples. One is on the troubleshooting of the existing broadband networks. And frankly speaking, till now, we don't have too many effective ways to do a proactive network maintenance or troubleshooting or preventing any kind of network risk comes to a problem. The troubleshooting on the existing networks are mainly still driven by the complaints from the broadband consumers. Then that caused to the insatisfaction of the broadband subscriber and the trend of the broadband subscribers. We know we listed some of the numbers here as an average level. The broadband operators spend quite a lot of money to develop up subscribers. But when there is a problem happens, and they have to assign on-site technicians to do the debugging or troubleshooting, and cost even more, higher cost of that. Is there any way that we may find that the health status of the network and trying to do something before the problem really happens? Is one of the topic of this kind of software-defined or virtualization of the network. That's one purpose. Another one is the deployment of the new services. And we have to say that the existing telecommunication networks is still not really decoupled of the network and the services. And most of services are still coupled with the equipments. We have a lot of dedicated purpose-designed hardware. We have BRAS for broadband services, right? We have EPC, we have IMS, we have a lot of dedicated equipments for different kinds of services. If we compare with the, let's say, for instance, for our OTT industry players, the speed for deploy of the new services differs quite a lot. For OTT world, the new services deployment takes hours level. For several hours, they may install new services at the cloud. But for telecommunication services, probably months, or even 1 year, 2 years, it takes to change the network to support new services. And to do the OSS integration is is one of the biggest headache when we support our customers to do. The network is composed with multiple of the equipments, and equipments is purchased from different vendors, and different vendors have different releases, hardware releases, software releases, and different interfaces. And to integrate the services always takes half a year, 1 year. Is not something. It's an ordinary life for telecommunication operators. So, is there any way to speed up, to increase the efficiency of the network, of the service deployment is another topic. And on the maintenance also thing. Also, as a comparison with the OTT world. And as an average level, according to our estimation, for each of the maintenance engineer of the OTT network, they may maintain around 3,000 to 4,000 of the physical equipments by just one engineer. But these numbers for the telecommunication operators are around hundreds level, 100 to 300 equipments, physical equipments. So it's about 10 or 1/10 capability compared with the OTT physical network. What is the way to do it? Is a kind of this intent-driven concept. This is not just something generated by Huawei, but we collected a lot of ideas and also to define this architecture with our customers together. As a fundamental one, definitely it's still an physical infrastructure. I listed here just the fixed broadband part from the central offices, starting with the ORT, with different kinds of fixed access technology, and to the home network, and also to the premises network by residential broadband, business campuses, and probably the mobile base station. And this could be considered as a body of the human being. In the past, we have the body, but we have the feelings of that. But all the operations are also on that. And to separate the operation of that and the thinking capability of that, so what is important is to set up a brain. So there's a brain in our idea called it network cloud engine. In this cloud engine is responsible actually for two cycles. Firstly, it has to feel all the organs of this body. So it is about the intelligence cycle. There is an intelligence engine, collect all the informations, big data, of the physical network. And when the big data is collected, there is a lot of imagination room in this brain to do and to take effect into this network. Now that a lot of technologies may be introduced here, big data analysis, machine learning, artificial intelligence, could all be made use to monitor, to manage, to operate, to feel this physical network. So that's from the intelligence cycle. So another cycle is about the automation. So with a lot of data collected from the physical network, so we may do a lot to guarantee that the operation of this one is automatic. So the productiveness, programmability, and also automatic operation management and could all be implemented according to this one. So from the purpose perspective, we're trying to move from the network-centric to user-centric. It's fragmented to closed loop, for instance. And according to the network construction cycle and network operation cycle. It is from experience level. But we focus, some examples are, for instance, for the simplicity. The simplicity doesn't really mean that the network architecture is simplified, but actually the utilization of this network is really simplified. It is a very easy way to use the network, and we don't need to care about the physical infrastructure of it anymore. We just need to consider the feeling from this intelligence cycle. And also automation. And the previous two speakers are all discussed about automation on mobile network, on the edge network. So it is a similar consideration of that. Furthermore, if virtualization and prediction. But till now, it is still about the implementation and the architecture of that. And so also in the industry, there was a lot of discussion on the implementation of that. For instance, the SDN. SDN is a word of the implementation. It's a technical word, right? Virtualization, cloudification, and so DevOps, so re-architect, and white box, different color of boxes, white box, gray, black. That's all about implementation. But the implementation about the architecture is important. But furthermore, when we define the architecture, we have to solve some kind of a problems. It is an application scenario. It is a use case. So later on, I'd like to just raise 3 examples, 3 use cases, and to show what we support our customers to do with this network brain and the network body. The first case is about the abstraction. And so which means that we are trying to set up the abstraction of the network. In the past, as I mentioned, that the network, the physical network, is still coupled with the services, with the operation system of the operator. For each of the new changes of the network, a physical network, even we upgrade the software or change the same function but to a different vendor, or we upgrade from the previous, let's say, DSL technology to fiber, or even for different generation of the optical access network, we have to modify the operation system. That takes time and also bring the headache of the efficiency. The way to solve that is we don't need to concern about the physical implementation of that. From the network operation perspective, what should be considered is the application layer, is the service abstraction of the network. The operation system need to care about just the service implementation. Leave the physical implementation to this brain. And this brain understand clearly how does its body works on each of the organs, each of the finger, each of the legs, arms. So the brain will interpret the intent from the operation system and provide just the several abstracted, let's say, the API interfaces or profiles, parameters. And these parameters will be unique for all the physical infrastructure of the existing network. And even when this physical infrastructure will change from the existing one to the new generation technologies, new generation architecture, but the service abstraction will kept the same. In this way, that the network isolation is implemented from the physical one and the service implementation. By that way, and we got obvious benefits on, at least, for instance, for the service deployment, for the OSS integration, for the new service delivery, and for the operation network configuration and any new service introduction of this network, of the broadband network. So this is one example. We support this. We use this kind of mechanism to support a lot of changes. For instance, our customers are moving from the DSL network into fiber to the home, or from the existing fiber to the home to NG fiber to the home. With this one, they don't need to care any changes of the physical network, but kept all the OSS interfaces unchanged. And when the network is constructed, it is plug and play. All the service parameters will be configured into the physical nodes automatically. So that's the first use case about the deployment automation. Another case is about the virtualization visualization of the network, and also that's mainly for the troubleshooting. We mentioned that it is about the intelligence cycle from the physical parameters, big data analysis. This is from another headache of the existing complain and solve cycle, and there is always a problem that is not really repeatable. For instance, we mentioned here, for instance, for video services. To guarantee of the video services quality is quite complicated loop. It is because of the services loop is quite long. When there is any nodes got faked and there is a problem, so there will be influence on the video services. And so what the solution for that? Based on the big data, there is a powerful analytic engine at the brain of the network. So all the nodes will report his status to the specific services, video, for instance, to this brain. And the brain will understand the feeling of each of your organ on the video services, and to draw a health curve of that. And even to do the prediction, because we have a historical record, we know that when there is some conditions happens, there is a unhealthy status happens, and to do the preventive maintenance. And we have historical record. When the broadband subscribers complain that he got some kind of problem of the video services in the past, we may just to replay the period of time, the past period of time, to find out where there's a problem happening in the network. So this is another way, and use the visualization of the visualization. And the third use cases, this is also mainly highly concerned in European areas, since that there is always this kind of a cooperation of the ISP and the NSP. And so in the past, NSP, so network service provider, takes a lot of responsibility to provide different kind of services to internet service providers. They have to define which kind of services could be supported by the ISP and define the OSS interfaces to the ISP. But there's also the way to do the isolation with this kind of network cloud engine, and to clarify the responsibility for different service providers, NSP and ISP. One for physical part and their own services, but another one for the wholesale services. So that's also isolated to define which service and to each of the subscribers, to each of the service providers, and also to each of the service provider groups or customer groups. This is another 3 examples on that. So just make use of the 3 cases to explain. And these 3 cases, I think that's also the highly concerned use cases that when we talk with our customers. And nextly, that was my summary page of the presentation, is that I started with the title of the Cloud Central Offices. Is there any relation between that I presented in the past of the use cases and the Cloud Central Offices? But actually, Cloud Central Offices is relatively a big concept. What we discussed in the previous presentation is actually still on the physical network part. But the physical network part is actually a very fundamental part of the overall Cloud Central Offices. With this kind of PNF, I believe that the next speaker, Ms. Mersch, will bring more information on that. The whole industry may work together to set up the basic infrastructure of the data center, and also different software functionality for different services, and also the service chain and reorganization, for etc. to implement the cloudification of the big central offices. And actually, there is a lot of also the open source or standardization group are working on that way. And when each of the bricks are collected together, that we may get the entire building of the Cloud Central Offices. So as a summary word, the intent-driven fiber to the X is the cornerstone for the Android broadband services, enabling, actually a lot of imagination rooms. I would like to raise the use cases, but not least that one. There is more imagination rooms on this kind of migration approaches. So I completed my presentation. Hope there is time for questions.
Not at this time, unfortunately.
Okay. Okay, so we may talk offline, probably. Thank you.